This is Euclid Book 9, proposition number 15. There you are. Okay. And it says, if three numbers in continued proportion be the least of those which have the same ratio with them, any two whatever added together will be prime to the remaining number. Let A, B, and C, three numbers in continued proportion, be the least of those which have the same ratio with them. I say that any two of the numbers A, B, and C, whatever, added together, are prime to the remaining number. Namely, if you add A and B together, it'll come up to C. If you add A and B together, it will be prime to C. If you add B and C together, it will be prime to A. And if you add A and C together, it will be prime to B. For let two numbers D, E, and EF be the least of those which have the same ratio with A, B, and C be taken. This is by Euclid Book 8, proposition number 2. It is then manifest that DE by multiplying itself is made A. Okay. DE times DE makes A. DE times EF has made B, and EF times EF makes C. Alright. You say, well, what am I? You mean that? Okay, hang on. It is then manifest that DE by multiplying itself has made A, which we just said, and by multiplying EF has made B, which we just said, and EF by multiplying itself has made C, which is by Euclid Book 8, proposition number 2. Now, since D and EF are least, they are prime to one another. D is prime to EF. Now remember, they're not prime numbers, they're just prime to one another. This is by Euclid Book 7, proposition number 22. But if two numbers be prime to one another, their sum is also prime to each. This is by Euclid Book 7, proposition number 28. Therefore, DF is also prime to each of the numbers DE and EF. Okay? So DF is prime to DE, and DF is also prime to EF. DF is prime to DE, DF is prime to EF. Okay. But further, DE is also prime to EF. Therefore, DF and DE are prime to EF. Okay? But if two numbers be prime to any number, their product is also prime to the other. This is by Euclid Book 7, proposition number 24. So the product of DF and DE is prime to EF. So, if you take DE times DF, you'll get EF. Now, well, it'll be prime to EF. I'm sorry. If you multiply DE times DF, it will be, that answer will be prime to EF. So if you multiply DE times DF, that product will be prime to EF. That's what they're saying. Hence, the product of DF and DE is also prime to the square on EF. This is by Euclid Book 7, proposition number 25. So, DE times DF will be prime to EF times itself. Okay? And this is by Euclid Book 7, proposition number 25. But the product of DF and DE is to the square on DE together with the product of DE and EF, which is by Euclid Book 2, proposition number 3. So, DF times DE is the square on DE together with the product of DE and EF. Okay. So DE times DF, this times the whole of DF, is equal to the square on DE, that would be DE times itself, together with the product of DE and EF. So you take the square of DE, alright, that answer you add to the product of DE and EF. Let me show you that one. So we'll square this, then that answer we're going to take times the product, well, we're going to add it to the product of DE and EF. Okay? Now it's a lot of multiplication there and a lot of addition. Therefore, the square on DE together with the product of DE, EF is prime to the square on EF. And the square on DE is A. Now the square of DE, this here times itself is A. Okay. The product of DE and EF is B. So DE times EF is going to be B. And the square on EF is C. EF times itself is C. Therefore, A and B added together are prime to C. So A plus B, that sum, will be prime to C. This plus this will be prime to this. Let's go on here. Similarly, we can prove that B and C added together are prime to A. I say next that A and C added together are also prime to B. For since DF is prime to each of the numbers DE and EF, the square on DF, okay, so DF times itself, is also prime to the product of DE and EF. So DE times EF is prime to DF times itself, which is Euclid Book 7, propositions number 24 and 25. But the squares on DE and EF together with twice the product of DE and EF are equal to the square of DF, which is by Euclid Book 2, proposition number 4. Okay? So, the squares on DE and EF. Well, that means that DE times itself and EF times itself, if added together with twice the product of DE and EF, so you take DE times EF and you multiply that by 2, and you add that to the other that I just mentioned, it's equal to the square on DF. So that would be, that whole thing that I was just talking about a second ago is going to be equal to DF times itself. Okay. Separando. The squares on DE and EF together with once the product of DE, EF are prime to the product of DE, EF. Therefore, separando again, the squares on DE and EF are prime to the product of DE and EF. And the square on DE is A. Okay, so DE times itself is A. And the product of DE and EF is B. So if we take DE times EF, we get B. And the square on EF is C. EF times itself is C. Therefore, A and C added together are prime to B. So if we add A plus C, that sum will be prime to B. And that's the end of the proof, people. I will tell you more in a future video. Stay tuned.